Bismillahirrahmanirrahim. Welcome to International Research Class. For this time, we will discuss about the sum method in the estimate the parameters, like the maximum likelihoods, Bayesian Mcmc law, and Lmomen. First two of these methods we have discussed in some discussion in Rado Institute. So if you want to take the more information about the how to use the maximum likelihood and Bayesian Mcmc law, especially in the estimate the parameter of generalized extreme value, generalized logistics, you can join with the www.radoinstitute.com and you can find all the tools of the Rado Institute, namely International Research Class. For this time, based of one research article, I think this very good research article. There's a research article published on the Mathematical Journal with the title of the article, Fluid Frequency Analysis using Lmomen for Segamat River. In this research article, there is the simple ways to use the Lmomen in the estimates parameter for the sum distribution function, like generalized extreme value, generalized logistic, log percent, log normal, and then the other distribution function. Based on this research article, we can understand the Lmomen depend on the first four components of unbiased simple estimators, like in the equation 2, 3, 4, and 5. We can check here in the equation 2, B0 equal to 1 divided n multiplied by summation the data. The data, we must sort the data from the smallest to the greatest data. So if we want to find B1 automatically using the formula 1 divided n, summation start from 2, I from 2 until n, and I minus 2, I minus 1 divide n minus 2 minus 1 multiplied by xen. Xen is mean the data you sort from the smallest to the highest. Okay, and then B2, B3. This is the very important equation to understand how to use the Lmomen. After we understand about the full equation, we can come to the equation 6 until equation 9. The equation 6 until equation 9 is the first four sample estimator for the Lmomens. We can find here L1, L2, L3, then L4. For example, L1 in the equation 6 using the formula B0. B0 we can using the equation 2 to solve the problem about the B0. And then for the L2 like equation 7, we use the formula 2 multiplied by B1 minus B0. B1 we can using the equation 3 to solve the problem what the value of the B1. Okay, after we understand about the equation 6, 7, x9, we come to the equation 10 until 12. The equation 10 until 12 is the sample of Lmomen ratio. Okay, after we understand about this equation 2 until the equation 12, we can check in the table 2. The table 2, there are the formula to estimate the parameter of the sum distribution function using the Lmomen, like the GEV. GEV is its mean generalized estimated value using the quantile function. I think there is some mistake on this paper. This in this table 2 is mean the quantile function, not cumulative density function. I think this is some mistake from the authors. And then you can check here. There is 3 parameter in the GEV. We call that C, alpha, and kappa. When we are want to using the Lmomen to estimate the parameter of kappa, we can use the formula 7.x9x90C plus 2.9554 C power 2, where C is equal to 2 divide 3 plus T3 minus logarithm natural 2 divide the logarithm natural C. In this one, we can find the first time what is the T3. T3 you can find from the equation 11. Okay, in the equation 11, T3 we can use the formula L3 divide L2. And what is L3 and what is L2 we can find from the equation 7 and equation X. In the equation 7, L2 equal to 2 power B2 minus B0. And then the equation X, L3 equal to 6 multiple B2 minus 6 multiplied by B1 and plus B0. B0, B1, and B2 we can find on the equation 3, 4, and 5. Okay. So in this research article, so very clearly how to use the Lmomen to estimate the parameter. You can doing by the manually, but in this program we are not use them manually, but we are use the R programming to solve the problem how to estimate parameter using the R programming. Okay, we can open our R programming. Stop share, and then we come to our R programming. Okay, this is our R programming. Okay, you can check from your house. There is the nice R programming that you can adopt, or you can use this programming to solve your problem. Maybe you try to make the result about the sum even, but you using some distribution function. So automatically you need this program. Okay, in this program we have the maximum temperature data. Okay, so that's why we try to open our data. Open our data, read.csv, file.use. Okay, enter. Okay, we can try to open our data about the maximum temperature. Okay, this is our data, maximum temperature data. You open here. Okay, after that, you type the data. Okay, in the data, you can check here, there are 12 station data. For each station, we have the 21 data. 21 data, it means we have the 20 years. For each years, we take the maximum temperature. So, of course, if we have the 20 years data, 21 years data, so automatically we have the 21 data. because for the each years, we take only for the maximum data. Okay, for our case study, we only try to solve the problem using the one station. Okay, we can use the station 1. The station 1, we call the data 1. Data 1, it means the data, but we text only in the column 2 or the second column. Okay, we can type data 1. This is our data. After we have the data, in our program, we use the Dmax. Dmax is specially for maximum likelihood, and Z specially for Bayesian Mcmc, and DTT is specially for the Lmomen. So we have the 3 kind of data, but it's the same data, only different name. So automatically we give name Dmax. Dmax it mean data 1. And Z it mean Dmax. And DTT it mean Z. So you can check here Dmax and the Z and the DTT, the same data. We try to make different name for 3 cases of our methods. Like I said before, Dmax we use for the maximum likelihood. Z we try to use for the Bayesian Markov chain Monte Carlo. And DTT we use for the Lmomen. After we have the data, the next, we are trying to solve our problem to the estimate the parameter. Okay. When you are trying to use the Lmomen technique in R, there is the one package, namely Lmom. Lmom is special package only for to estimate the parameter for the sum distribution, like GEV, GLO, and another distribution function. So you must try to install the Lmom package. For our discussion today, I have installed the package. You can check here. You can come to the package. You can click the load package. After you click the load package, you can check there are some packets. We need the Lmom packet. So you can see here, there is the Lmom package. If your computer or in your laptop, you can found the Lmom, it means you are success the install the Lmom package. After you install the Lmom package, you can try to estimate the parameter using the tool SumLMU. Okay, SumLMU, it means you are trying to using Lmom package. Okay, this is standard programming. You cannot change this as standard programming. You must use only. Okay, try to use the Lmom equal to SumLMU data. You can run, and then to estimate the parameter, you use the Gev. Gev is the standard name for the Lmom package to the estimate the parameter. So that why you run the par is mean the Gev Lmom. Okay, you can run here. Okay. Oh, you can check here. You can type the par. So if you type the par, the program or the Gev Lmom will give you the 3 parameter for the GEV distribution. There is the C parameter, alpha parameter, and kappa parameter. After we success to the estimate the parameter, we need take the parameter one by one. Okay, in the R programming, to take the parameter one by one, we must use the sum. Some are programming like the par one using double cricket for the MU2, and the theta 2 use the par double cricket 2, and eta 2 use the par double cricket 3. Okay, you can run here. You can run here. Okay. And then you come to the console. You type the MU2. And you can type theta 2. And you can type the eta 2. You can check here. MU2 is represent for the C. Theta 2 is represent for the alpha. And eta 2 is represent for the kappa. Okay, we are success to the estimate parameter for the GEV distribution. After we take the parameter by using Lmomen, and then we use the another methods like the maximum likelihood and the Bayesian Markov chain Monte Carlo. I think these two methods we have discussed for the some discussion about the maximum likelihood and the Bayesian Markov chain Monte Carlo. And I think for these two methods, it is not important again to take the much time to discuss about the two methods. You can come to the www.radioinstitute.com, and then you can find our discussion about the likelihood method and the Bayesian Markov chain Monte Carlo method. Okay, so that's why in this program, we just run only. This is for the maximum likelihood. We can run here. Okay, after we run, we can check what is the theta. The theta, we can type the theta. We can type MU. We can type the eta. So we make the comparison with the parameter by use the estimates by using the Lmomen. Like I said before, MU2, okay, and theta 2, and then the eta 2. You can check here the parameter C or mu by using maximum likelihood xt6.xtx blah blah blah, and by using maximum likelihood xt6.xtx6 blah blah blah, and using Lmomen xt6.67. So very small difference. But if we take the comparison about the kappa parameters, when you try to maximum likelihood, you can find the kappa parameter minus 0.62. But by using Lmomen, you can estimate the parameter kappa and have the value 0.61 blah blah blah. So very different between the kappa parameter from the GEV distribution when we use the maximum likelihood method and the Lmomen methods. So of course we need some method to the max comparison about the two methods to choose which one is the best. Okay. After we run the maximum likelihood, now we can run by using Bayesian Markov chain Monte Carlo. Okay, I think it is not important again to take a long time to discuss about the Bayesian MCMC because we have already discuss about this problem. So we just only run our programming. You can check here. We run the Bayesian Markov chain Monte Carlo. You can run here. Okay. Okay, this one, run here. And then we come to the console. Okay, we wait. Needs the little time to the process of the parameter when we are using Bayesian MCMC. Because like I say before, we are use the 30,000 burning. It means we must have the 30,000 for the new parameter. We must have the 30,000 for the theta parameter, and we must have the 30,000 for the eta parameter. Because in the Bayesian MCMC, we are using the 30,000 times burning. So, okay, we are success to run our program. We can check the ME1. Okay, we can check the theta 1. Okay, and then we can check the eta 1. Okay, we now have the 3 methods to the estimate of the GeV distribution for the maximum temperature data. When I say MU, it means this is the C parameter using the maximum likelihood method. But when I see MU, when I say MU1, it means the C parameter for the GeV distribution using the Bayesian MCMC. But when I say MU2, it means the C parameter for the EV distribution using the Lmomen methods. So we have the different names. If we are use one, it means they comes from the Bayesian MCMC. If we give the number 2, it means this come from for the Lmomen. So after we have the all parameter for the EV distribution using the 3 methods, we must check which one is the best. Okay, for this time, we will use the graph methods to the max comparison. These 3 methods. We are using the density plot, and we are using the cumulative plot. Density plot, it means how good the density function capture the histogram. Cumulative distribution plot, it means how good the cumulative distribution to the capture cumulative observation. Cumulative observation, it means we are use the formula equal to I minus 0.5 divide N. I, it means the number 1 until the length data. And N, it means the length of the data. So we have designed the best R programming in this program. You can check here. If I say SXE, it means you must need the long series data from the 0 until the 2 multiple maximum data with the step 0.01. It means we have the long series data start from 0, after that 0.01, after that 0.02, until the 2 multiple maximum data. You can imagine that we have the long series data. After we have the XXE, we must give the density of GeV function. I give the name FGeV. Okay, it means density function by using maximum likelihood. If I say if GEV okay B, it means the density function using the Bayesian MCMC. And the last one, if I say FGEV OKL, it means density function for GEV Lmomen. Only this very simple to find the difference. You can check here. In the maximum likelihood, we only use the theta here. But when we are use theta 1, it means we are use the Bayesian MCMC. But for the theta 2, you can understand this comes from density function using the Lmomen. So we have the 3 density function by using the parameter from the 3 methods that we use in this our program today. So after that, we are trying to make the comparison for the plot for the 3 methods in the estimate the parameter. Okay, you can check here. We run here. Okay, we run. So we can see the comparison from your house. You can see here, there is the 3 graph, the blue one, the green one, and the red one. The blue one is representative for the maximum likelihood. Green one is the representative for the Lmomen. And the red one is the graph density function by using the Bayesian MCMC. And then you can check here. The blue one is the best from the others colors. So it means maximum likelihood still have the best way to the estimate the parameter for our discussion using the maximum temperature data. After we have success to make the density plot, now we check by using cumulative distribution function. Okay. Don't forget, when we use the cumulative distribution function, we need the I parameter. I, it means the number 1 until the length data. And NN, it means the length of our data. The length of our data, it means in our case today, we only have the 21 data. So it's meant the NN is the 21. So we need the cumulative for the observation. Like I said before, cumulative for our observation using the formula I minus 0.5 divide N. So in the cumulative distribution function, we need XX. XX, it means sort the data from the smallest to the highest. Okay, after that, when I say GEV, it means cumulative distribution function comes from the maximum likelihood. When I say GEVB, it means cumulative distribution function by using Bayesian. But when I say GEVL, it means the GEV by using Lmomen techniques. It's very easy to make difference from the 3 of cumulative distribution function. You can check the parameter. If I say eta 1, you must remember when I use the number 1, it's come from the Bayesian MCMC. But when I use the number 2, it means comes from the Lmomen techniques. So very easy to understand what is the difference from the 3 cumulative distribution function. Okay, after that, we can run this program. Okay, you can check at your home. Okay, we run here and then you check. Okay, you can check here. Like I said before, we have the 3 graph. The blue one representative GEV by maximum likelihood. The green one, it means GeV by the Lmomen. And the red one, it means GeV by the Bayesian Mcmc. And you can check here. The blue one is very nice to the capture GeV observation. So it means from the density plot and the cumulative distribution function plots, we can conclude that the GeV by using maximum likelihood is the best method. So when you check the some research article have the same conclusion with us. Okay, we have the same conclusion where we believe that maximum likelihood is the best way to the estimate parameter when we are trying to make comparison with the Bayesian Markov chain Monte Carlo and the Lmomen techniques. Okay, I think it's very nice discussing for today. So I hope what we discussed today can help you to produce the best result. Okay? Don't forget, if you have the problem, can contact Rado Institute. Only come to www.radoinstitute.com and you type the message, and then I will respond your message. Okay, I think enough for this today. Rado Yendra International Research Class.